All right, thanks for the invite, Drew. Always good to be back here. And again, I want to just really showcase the partnership, the strong partnership that we have with Drew and the LA County Fire and all the Southern California fire agencies as a whole. But how we work together, for those who have not seen me before, kind of the behind the scenes of how we work together for the National Weather Service and the fire agencies. So we're going to look at kind of a recap of the season and the fuels situation and where we are in terms of seasonal outlook, projection through the summer. We're going to highlight the Red Flag Warning PDS program. And at the end of it all, it's really about decision support, how we are providing information and products and services to help you all make better decisions. That's the main theme of the National Weather Service. Okay, a couple changes for those who haven't seen us before here. So my name again, Dave Gomberg. I'm the Fire Weather Program Manager at the Weather Service in Oxnard. If you haven't called our office and you're in our area, and by the way, our forecast area covers LA, Ventura, Santa Barbara, and San Luis Obispo counties. Office to the south in San Diego, office to the north in Hanford and Monterey. So that phone number, 988-6626, that's the number you want to program into your phone, and that's a dedicated 24-hour number. Many of you have probably met my manager, Dr. Ariel Cohen. He came here a couple years ago to present as well. A new person in the warning coordination meteorologist. That's an important person, kind of like the PIO of the office, in charge of all of the partnerships of our region, and that is Todd Hall. He was a senior forecaster like myself who got promoted into that position. For those of you who may have worked with Eric Bolt in the past, he's the replacement for Eric. And then, of course, Rich Thompson, who's been an incident meteorologist. Many of you have probably worked with Rich. Been on fires for about 20 years now. Okay, so kind of a recap. Over on the left is the rainfall situation that we had for this past season. You can see the green areas reflect the above normal precipitation that we had in Southern California. And in the northern half of the state, you can see the browner colors where we were in a below normal rainfall status. So as that's translated into the drought situation, you can see last year at this time, we had quite a bit of areas of orange and red, indicating the drought. And you can see quite a bit of improvement in the left-hand side for this year, except in Northern California. Again, the drier precipitation is reflecting some drought situation up there. So as far as live field moisture, Drew, I don't know if you want to jump in here. Talk about.
Keep going, okay. Sir. You got all the good info.
Okay. So basically, where we're at, generally across the region, we're about anywhere from about 80 to 110% on live field moisture, starting to take that dip down as we head into the summer months here. So as far as seasonal outlooks, this is the predictive services projection May through August, and you can see their projection is for pretty much a near normal in terms of large fire potential. However, a couple of key caveats here. They are highlighting the above normal sea surface temperatures that we have off the coast right now, and that's going to reflect in a warmer temperatures, really, that will continue right through the summer, and as a result, in general, a shallower marine layer influence, okay? And most importantly, we're going to highlight is about El Nino projections later in the season, especially as we get into late summer, fall, and winter. That could result in enhanced monsoonal and tropical remnant moisture by the late summer. So these are the official Climate Prediction Center models from back east, and these show the projections of temperature over the next 3 months. And you can see, as expected, a pretty big bullseye of above normal temperature probabilities for the western United States. And that trend really continues right into the summer and early fall months. West Coast dominating with above normal temperatures. Now, as far as precipitation, this is the projections for May, June, and July. You can see the most important signal here is the enhanced monsoonal activity across Arizona and New Mexico, but really not much of a reflection into Southern California at this point. However, once you go into August, September, and October, they are starting to show a little bit of an increase here across southeastern California. So as I mentioned, El Nino is going to be the big topic as we move into the rest of the year. And what this shows, let me go to this slide first, this is just to understand what El Nino means. It's really the above normal temperatures, specifically highlighting in this area of the eastern Pacific. Okay, when those areas go above normal temperatures, that's what we classify as an El Nino. When it's below normal temperatures, that's a La Nina. So going back to this slide, this is showing projections of probabilities. We categorize El Ninos by different strengths. If you get at least a ½ degree Celsius above normal, that constitutes a weak El Nino. Once it goes above a degree Celsius above normal, that's a moderate. Then a 1½ degrees Celsius, strong and very strong, would be above 2 degrees Celsius. Now that doesn't seem like a whole lot of temperature, that's very small degrees above normal, but when you average that over a large area of water, that gives enough energy source region to generate more storm activity. Now the question is, what is our projections as we move on through the season? And this is what's showing you. The red areas basically are indicating we're going to have some sort of El Nino. It's almost a given. The question is whether it's going to be weak, moderate, strong, or very strong. But what you can see as you get towards the fall and early winter, look at how the red and dark red areas, that shows at least a strong to very strong signal. So what that tells us is that there's at least a 50% probability of either a strong or very strong. So that's significant. This far out to see that kind of projection is pretty unusual. However, word of caution is that just because we're indicating the potential for strong to very strong, everyone wants to make that automatic correlation to heavier rain across Southern California, but that's not always the case. We've had 7 El Ninos that are strong. 6 of the 7 were above normal rainfall across Southern California. However, we all remember 2015, where we were advertising a strong El Nino, and we actually had below normal rainfall that season. So the main takeaway is that it skews the odds higher probabilities for sure, but where the axis of heavier precipitation and where the jet stream focuses can sometimes be more up in Northern California like it did in 2015, or sometimes it skews a little further south toward Texas and Florida in the southeast. So Southern California is not a guarantee for above normal rainfall. Okay? Okay, so as I mentioned at the onset, the name of the game for our agency is decision support right here. What can we do that helps fire agencies better plan resource levels and strategically place equipment and fire personnel for rapid initial attack? And that's where we work together so closely behind the scenes. Go back here. There we go. So this is kind of a summary of the products and services. Just real quick, we have a fire weather planning forecast, which kind of gives the big picture forecast for the next several days. Many of you are probably familiar with our trend forecast, which is really highlights that strong partnership that we have with LA County Fire over the years. And this year is kind of unusual because we've transitioned to a new system called the FEMS system, F-E-M-S. Before it was WIMS, now it's FEMS. Really the bottom line is there's going to be some work on both the Weather Service side and on the fire side, but at the end of the day, the end result is still the same. We're still producing point-based forecasts for all the RAW stations. So every RAW station that LA County Fire has, we're providing a point forecast for that location. And out of that, from the wind and RH forecast comes various indices, including the burn index, which generates a staffing profile for LA County Fire. So they look at 97th percentile, and out of that, They can also look at historical fire information as well. So there's a lot of value within the forecast from the Weather Service that feeds into these indices that at the end of the day is a decision support tool for their planning of resources. Did I miss anything on that, Drew?
No, sir.
Good? Okay. So let's go and give you an example of that. This is the fire danger rating analysis. Probably can't see the numbers, but again, this red box right here, that's the VIs for the various cross locations. And these are the forecast inputs that are coming from the Weather Service. The one main advantage, or actually really two main advantages of the new system, is that instead of it being locked to just 2 o'clock from observe to forecast, you now have 24-hour access to data. So sometimes our peak wind events are going to be outside of 2 p.m. So this BI could reflect some of these higher wind thresholds that come at mid-morning during Santa Ana, or perhaps a sundowner in the evening hours. Okay, so how many of you are on our 1 p.m. fire calls? Okay, for those who are not and are in our area, again, if you want to get signed up, this is really where a lot of the decision support is taking place. And really, when we think about fire weather watch, red flag warning, PDS decisions, we try to culminate that at 5 this time. You know, we try to have that decision made. There's a lot of times there's pre-coordination that we do. A lot of times I'll check in with Drew in terms of fuels, even before the 1 o'clock call. But 1 o'clock is where we can gather everybody together and discuss. So primarily for our high-impact fire events, it's not like an everyday thing, it's event-driven. But we also do it for heavy rain flood and also high wind events as well. And really it's a great collaboration. You know, when you think about, we have all the fire agencies, we have Forest Service, we have emergency management from each county, we have our storm prediction center, we have predictive services, so we really have all the players all together at once. Okay, so that brings us to fire weather watches and red flag warnings. Just to recap, again, think of the fire weather watch as kind of a lead-in to a red flag. It's I like to think of it as at least a 50% probability of red flag conditions, so not a guarantee. And then, as far as lead time, that's roughly about 48 to 72 hours, with occasionally up to 96. Okay, so that's 2 to 3 days, occasionally up to 4. And then red flag warning means that when the fire weather watch conditions, there's a high confidence we would upgrade that watch to a warning, and that would typically be within a 24-hour period, occasionally as high as 48 hours. So the criteria, just to refresh those, and for those who haven't seen it before, sustained winds for criteria 1 have to be 25 miles an hour or greater, or gusts of 35, with an RH of 15% or less. Or if your humidities go down to 10% or less, then the sustained wind only has to be 15 with gusts of 25. Both of those need a duration of 6 hours or more, and all require sufficiently dry fuels. There we go. Okay. Okay, so sufficiently dry fuels and a duration of 6 hours or more. Third criteria would be widespread dry lighting. And fourth could be a forecaster discretion, such as a large plume-dominated fire activity in the summer. We see that on a more regular basis lately, where almost once a year now it seems like a strong coordination again. A lot of times Drew and I will talk about these heat waves where there's heat and instability, such as bridge fire, such as the Bobcat fire, station fire. A lot of these large summertime fires that can't be really captured with criteria 1 or criteria 2. Okay, mixing height also comes into play on those events. Right, exactly. So what Drew is saying is that not only the 1 o'clock call, but the pre-coordination, where Drew was actually right on top of it, right before the bridge fire. He was seeing what we were advertising in terms of heat and mixing height, and he starts putting it into our head, like, hey, are we thinking red flag for heat-driven fire? And sure enough, we did. So it's that close coordination ahead of time that drives these decisions. Okay, so that brings us to PDS. Of course, they got a lot of attention the last couple of years. So the main idea here is that we know that all red flag warnings aren't created equal, and we want to show a sense of urgency that this is the worst of the worst type conditions. And that was designed in 2020, again, collaboration with the fire agencies, with our emergency managers, to come up with this terminology and also criteria. So what does the criteria look like? Well, remember, with regular red flag, it was 25 gust 35. With PDS red flag, it now has to be sustained 35 and or damaging gusts to 60 miles an hour, combined with RH of 10% or less, combined with critical live fuel moistures of 60%. So actually, to get all three of those together for 3 hours or more duration is actually quite challenging when you go back through history. So we wanted it to be a fairly strict criteria. Now 2024-2025 was unique because we had gone 4 years without issuing a PDS. In fact, 2020 was the first year we rolled it out, and we did have a couple minor PDS events in 2020, but then we went 4 years without issuing one. And then came the mountain fire, and then the Franklin fire, and then the firestorms. So what happened was the fuel stayed critically dry all the way through December and January. That left the door open to these powerful offshore wind events, okay, which culminated, of course, with the January firestorm. Okay, so the couple key takeaways with PDS is that it always originates from a traditional red flag warning and then gets upgraded as we get closer to that event. And the thing to remember is that PDS can be a subset of area or a subset of time of the overall red flag. So for instance, if you had a red flag for all of LA and Ventura County for a Santa Ana wind event, perhaps just part of those areas are actually going to hit those more strict PDS criteria. And let's say the duration of the red flag is 2 days, then perhaps only a certain subset of time the actual PDS is going to verify. So meaning it could be 6 hours, it could be 12 hours within the 2-day period. So here is the graphic that my Asa Ariel Cohen put together the day before, just to kind of give that visual attention, which definitely really was first of its kind, in my knowledge, to put out on social media. And he did a great job of conveying in that purple area on the fly what were going to be the most critical areas. Didn't mean that areas outside of that weren't going to have significant wind, but it was basically highlighting those PDS areas were going to be the worst of the worst. So this is another social media graphic we put out the day before on the PDS, just for the general public as a whole. And then just to give you a glimpse of this is what goes into the fire notes. So a lot of detail, bulleted information, and the key point here is the timing. When we issued the fire weather watch, we did it 4 days in advance. So it was 96 hours because we had high confidence. That's when we want to reserve the 4-day lead time on a watch, is when there's high confidence for a high impact event such as this. And then red flag, we were able to issue 48 hours in advance. And then the PDS was 24 hours in advance. So that's the chronology of our goal in terms of timeline. Okay, so this gives you some of the details that we highlight on the call, and then we send out these notes afterwards to convey some specific details that hopefully will help with decision support. And here's some additional information. Also, a thing that Drew and I like to do on the calls is to give historical analog, or a scale of 1 to 10. How bad is this event? What's the closest comparison in history? So in this case, it was the Pasadena windstorm of 2011, with the closest analog in terms of wind strength and mountain wave type activity. However, the main difference was the fuels were drier leading into the January firestorms, and the RHs were drier as well. Okay, so again, the key takeaway is how do we get this information to our partners, especially the fire community? And that could be a different format. So that could be in the form of that 1 o'clock call. It could be a gap call. It could be a webinar. It could be a direct call to someone like a Drew Smith. Or it could be partner email briefings. It could be Slack. We're on Slack now, and we're actually doing Slack huddles as events unfold, say during a winter storm. We can also provide on-site support. So in addition to Rich Thompson being an incident meteorologist, you can now ask for a meteorologist. That goes for any of the weather offices to help support either your fire or flood situation. And when EOCs spin up for major events, we're right there with the emergency managers during these events. So here's an example of the partner email format. And again, if this is something you're interested in signing up, either the 1 o'clock fire call or the partner email, just send me an email. My email is my name, david.gomberg@noaa.gov. And Slack, this is the slide here, and there's the information. John or Rose can get you added to that. And there again, as I mentioned, on-site deployment. And then finally, retrieving information off of our fire page. The main takeaway here is Fire Weather Snooper. How many of you have used Fire Weather Snooper before? Okay, for those who haven't, I encourage you to take a look. Not only for our office, but we have it customized for any weather service office in the region. And again, the main bullets here are that Fire Weather Snooper shows you in red or yellow areas that are either hitting red flag criteria in red, or yellow is approaching criteria. Also, there's a duration counter right here, so you can see how many hours you're actually hitting red flag conditions. So remember, our duration criteria for red flag is 6 hours or more, so you can start counting which stations have more than 6 hours of hitting that duration. You can also sort by clicking on the wind or RH. You can sort by the highest wind or lowest humidity. And when you hit the 3 tabs over there, it can also give you, you can get a 24-hour readout any particular station. Or if you hit the 3 bars again, you can go into map mode and get a graphical sense. Again, red being areas that are hitting red flag, yellow being areas where you're approaching red flag. And finally, another group partnership here. One of the meetings, probably 6-7 years ago, we had a discussion in one of our outreach meetings, and Drew said, you know, we have all these different websites at different areas. You have some are in the weather service, some are in the fire service, some are storm prediction center, we got forest service. Can we just have one page where we put them all the links together? And that's what the Fire One page does for you. Okay, so Drew, anything else? Any other words of wisdom?
See if the troops got in it.
Any questions for us here?
One right there.
Okay.
Are you responsible for high surf advisories as well?
Yeah.
Yes.
Dude,
That's
issue
fine.
PDSs for those?
No, the only thing close to that would be what we call high surf, not advisory, but high surf warning. And that's for another level up. So our criteria down south, what county are you in?
Ventura City.
Ventura City, okay. So for Ventura, it would be 7 feet or greater is regular high surf advisory. And then we reserve 15 or greater for high surf warning. Yeah.
And the lightning also you do for them.
Yeah, so lightning is the other thing for marine. If we have any kind of lightning anticipation, we'll call the lifeguards. That's really an LA County thing. We do that for them. And they shut down the beaches as a result of lightning coming in.
Can you repeat your email address again?
Oh yeah, sure. It's david.gomberg, that's GOMBERG, at NOAA.gov. So yeah, anybody feel free to send me if you want to join 1 o'clock or get the partner emails. I can get you added to that. Okay. Yeah.
So I got a question on a product for on a micro level. They using the satellite water vapor imagery for subsidence, being able to see the dry air along visibly. I know that's out there, but it seems like the weather service kind of, they don't teach it at 290 and all that, but that's a really cool tool that.
Yeah, absolutely. Yeah, well, I mean, we still use it in the office as a tool, for
Yeah.
sure.
Maybe explain what it's about.
Yeah, so water vapor is a type of imagery that's showing the moisture content in the upper atmosphere. So like you were saying, it really indicates nice areas of pockets of drying when you get subsidence on a high pressure system. Or of the opposite, when you have like an El Nino or an atmospheric river, it can show you how much moisture that is feeding into a system. Okay?
You mentioned about these wave red flags. Is that just only the LA office area you guys issue that?
Yeah, that's a good question. I'd say we've been more proactive with that. It doesn't mean other offices can't issue it. And I don't know for sure, like outside, like in Northern California, for instance, if they do that at all. But I know down here, of the 3 offices, San Diego, Hanford, and us, I think we're probably the only ones that do it. The only time it comes into play is with Hanford. I've noticed they have a secondary criteria when it's 10% or less humidity. So sometimes when you're in a hot pattern, you're going to dry out anyway. So they hit that 10% criteria. But kind of indirectly, they'll issue it for the heat wave based on that. What area are you in? Orange County. Yeah. They typically down there they stick to the just more traditional wind RH threshold down there.
Got one, Timmy.
Okay. Yes.
Hey, good morning, Dave. Hey, would you talk a little bit about your thoughts on the these new AI models that are starting to sweep the nation?
Sure. Yeah. So
That's how we did this whole thing. You caught him, Travis.
yeah, we are starting to look at some of the AI models. I've seen kind of mixed results on it so far. To be honest, I haven't. We're kind of evaluating it versus some of the traditional models. So the jury's still out. I mean, definitely shows some promise. And the other thing, outside of just the traditional models, we're looking at ways of maybe doing categorizations. What I mean by that is pattern recognition and feeding in with AI different patterns. Like say with Mount Wave, strong Mount Wave, like what kind of patterns set that up for those powerful windstorms off the San Gabriels or San Bernardinos, and maybe feeding that into AI. That's been talked about in terms of some of our upper level management. Okay, anything else? Okay, well, I'll be around today. Feel free to come grab me if you have any further questions.
Well, they're taking, I'm not going to go through my outlook, so I want to change it up a little bit while they're retooling for what's going to happen. I'll probably pick on Chief Hawkins. Big takeaway of what you saw today, sir. You lead it up because we're going to go interactive here.
Yeah, I think that the National Weather Service Los Angeles is on the forefront of the particularly forecasting, but the PDS. And as I look back on January, and I'm going to speak now, I'm going to take my hat off so I'm not representing anyone, but I saw a week out, 1 week out, the National Weather Service Los Angeles said, get ready for a serious wind event. That was number 1. That shook me. Number 2 was 3 days out. They said, we're into a red flag warning. There is no question. The wind event is going to be significantly worse. And then another day or so, the National Weather Service Los Angeles said, we're moving to a particularly dangerous situation. Now, where that mattered to me is just like we're learning here today. I had been to previous meetings that Chief Smith had put on with what we call the Susanna MTZ plan at Pepperdine, Calabasas, where David had been there and had instructed us what does a PDS mean. And a PDS was meaning that we were moving into, in my book, a 97th percentile time. And that was critical. Furthermore, what I picked up today is more from I saw earlier this week, on the El Nino and some of that stuff, and you really do a good job of doing that. But now I'm going to editorialize just a little bit for a short period of time. I believe that what's being produced by the National Weather Service needs to go to what I call a total forces concept. When we move beyond the 75th percentile day, which is perhaps the level of a red flag warning, we need to begin to have total forces available. That's fire, law enforcement, CHP, that's Caltrans, so that when we move even farther towards a 97th percentile day, then everyone in that geographical area where that prediction is needs to be on alert for a wildland or a brush fire. We need to be there. I firmly believe also that in unified command, we need to be in unified command, effective unified command, not unified presence, within 1 damn hour of the start of that incident. We need to be there in effective unified command. David Gomberg, Drew Smith, I thank you. Drew ought to be here with Jennifer Situ from the Los Angeles County Sheriff's Department and Keegan to talk about what they've done in the Santa Monica Mountains, because it's a model for California. I'm going to shut the F up.
So I'm going to throw a question in the group. So like the new, it's not new, it's just, it tells you when the worst of the worst on a PDS. So I want you to put on your fire behavior hat. Does that mean you're going to have more aggressive fire as compared to a traditional red flag? Throwing it out there. What does it mean to you as a first-in captain that's coming in and taking a division, being the ops section chief? Just pre-planning, what does it mean if there's a PDS as compared to just a traditional red flag? How does it change what you do before we go to the fire? Go ahead, anyone.
Staffing.
Staffing. Next.
Movement of resources to
No, Chief Hawkins, no, we already had this discussion on the way up there.
early evacuations.
Early evacuations, planning ahead. Now let's go into tactics. What changes you compared to a PDS, compared to a traditional red flag? What's the criteria? Let's think about options. Aircraft. So, like PDSs for me, going into this, when I see a PDS, I go, ooh. Our aircraft may be able to fly the Type 1 helicopter, but how effective are they? They suck, but it makes good eye candy for CNN or whatever news outlet, right? But you really have to think, can you have a faster rate of spread on PDS compared to, Tim, you can't answer this, and Tim in the back. Oh, we put all the Tims in the back, by the way. And Bob, you can't answer this either. Can you have a faster rate of spread under PDS as compared to a red flag that just targets 35 mile an hour winds? Maybe? You could? What does it mean with the residency time of it going through the brush with a 60 mile an hour wind compared to a 30 mile an hour wind, which can be more challenging? So you have to think infrastructure challenges. It shuts down your aircraft, what your options are with your aircraft, because that's the game changer from red flags. You about have the same rate of spread, and actually you can have more aggressive fire, 35 miles an hour. Under a red flag, you need to use 60 because of the heat energy residue sitting time it has on the landscape. But it changes your tactics on what you're able to do with everything, because one thing that it goes into is when they put in their messaging, this is what I like, the takeaway, is when they have infrastructure damage. And when you see that, it's going to change what your ability is to do. Maybe outside of the fire you're fighting, you may have damages with down trees and all this other stuff to complement or to handcuff you what you're doing outside the fire area as well. So PDS need to take seriously, and also because that infrastructure and also the tactics at tipping point, we all know in this room, 35 miles an hour is a tipping point for aircraft and how efficient or effective they are, right? As you get those wind speeds up, it's going to challenge you whether you're on the engine, division, branch, or ops. You're going to have to look at it differently. So, anyhow, Chief Tripp, you made it.
I did.
Duh, air attack, right on. Come on down. All right. Hey, thank you for everything. Please get on Dave's thing for the Weather Service and.